Okay, the reason I put this up is just a lot of words. We had a very good discussion. We first started talking about, well, what is it we want to model? And there's quite a bit of range in the room of what we want to model, ranging from processes, organizations, enterprises, to the environment and climate, to models for sustainability, from a socio-technical perspective, to hydrologic models, chemical reaction models, data, heat generation models. So there's quite a range of interest of what people wanted to model. The next question was, who's it for? And so, again, a range of senior management and policymakers, engineering functions, IT developers, model-based planning to design empirical studies to fill in where models don't have the right information or what you need, and then urban planning and stakeholders. Other users of the models were autonomous use, embedding the models in whatever the analogy of is a robot in that domain, and then other researchers. Some observations. One is the difference between a high-level description of the mathematics versus the source code or binary that is actually embodied in. There was one of our agreements you'll see later is the need to foster skepticism regarding models, especially their underlying assumption, the need to make models inspectable, especially for legacy models that were built a long time ago. So the question is, well, what's in here? What are we assuming? The need to make models evolvable in ways that are consistent with assumptions. When a new group evolves a model and adds on another piece, how do they make sure it's consistent with the assumptions that the model was first built with? And the provenance of the data. Where did it come from? How was it transformed before it was used to estimate parameters and other purposes? One other question was, how do you tell what the models are telling you? How do you understand it? Both the meaning and the implications of the outputs, but also the assumptions between the inputs and the outputs. A desire to go from reductionist science to integrative science. It's difficult, though. One notion is models as services. So the idea that you can send a query to a model and get a response from it that you then use in your other analysis. Integrative models, we talked about very carefully. Integrative models, not integrated models, are needed, and monolithic models are out. The idea of this great big mega model that you just put numbers in and get numbers out of. And that the insights gained are often more valuable than the particular numbers output. Modeling issues, questions of uncertainty, of course, structural, parametric, boundary conditions. Also the issue of whether or not the elements of the system actually learn and change. So the system is dynamic because the system is smart at various levels. And then the linkages of models at multiple levels, the need to write code to linkage. Sometimes these modeling packages are not readily able to communicate between each other. We had also an agreement on the need for multi-scale models, but scales mean different things in different areas. It could be spatial and temporal, abstraction aggregation. Some approaches were multi-grid, random cascades, hierarchical Bayesian, and then some of the traditional agent-based discrete event system dynamics. And then some of the tools that people use, and the whole question of how do these tools communicate with each other. Some of these off-the-shelf tools, commercial tools, are pretty closed. The need for visual analytics to be able to actually portray to the users the meaning of the outcomes. Ed also brought up an example that we didn't get time to explore of Urban Sim in terms of why that was developed and its implications. So what do we agree on? We agreed on the importance of multi-scale models rather than monolithic models. We agreed on the importance of skepticism and the inspectability of models. We agreed on a need for new paradigms to address large-scale, highly connected systems underlying sustainability that are more holistic and less reductionist. We agreed that the whole field needs both Darwins and Newtons, both people who are out there in the world collecting data and people who are working for more axiomatic approaches. We only had one disagreement. Right. But you'll see this posted on CNN shortly, or ESPN. Okay, that's what I have.
this screen. Okay. All right. So we were asked to do 3 points, and so this is not all we talked about by any matter of means, but the 3 points we came up with that I think we all agree on are that one of the big issues is sustainability of the sustainability data. It's a critical issue. How do we actually preserve this stuff because it might really be needed in 50 or 100 years, and we don't really have good mechanisms for doing this. A question that came up was, is NSF going to really want to pay for facilities and research on creating repositories for large amounts of data that we don't necessarily have a use for right now? And I don't know. I mean, how do we do this? I think we're helped to some degree because things will get cheaper. We had some discussion of clouds and how much more effective they are, and probably media will continue to come down in cost. On the other hand, there's an arms race. We have so many sensors that are getting cheaper and cheaper and easier to deploy that I'm not sure that we're going to actually find it cheaper to save the data. We may have, it may just stay the same, which is expensive. A second big issue is how do we actually share the data that we collect, especially if it's from proprietary sources like companies, or if it's data that has privacy or other kinds of issues associated with it that people may not really want to have shared. If we don't share the data, how do we really validate that the best algorithms have been developed to do it, or that the results are even accurate or believable? To some degree, I've personally dealt with this, and we have validation in that we make, our software particularly makes predictions, and if the predictions come true most of the time, that actually is one kind of validation. But is it the best prediction, or is it the most efficiently arrived at? I don't know. I mean, and it's not easy to know how we would actually do that. And I think that there are other obstacles. This isn't just a legal issue. I think there are different data formats, difficulties in joining things, the fact that you may actually need to know a lot about the data in order to even use it. Some discussion of tools that could help do this, which would be nice, and no doubt that we can learn from our experience, and this would be a valuable area to be able to generate tools that would let us take disparate kinds of data and put it in a more reconciled or cleaner form. Third issue, we have to deal with legacy data, not just the data that we're going to start collecting and desire. And in fact, especially for many of the topics in this workshop, we're very fortunate if we have legacy data, but we're also unfortunate in that the legacy data may not be what we wish was collected. And its quality, its completeness, its frequency of collection and whatever may leave a lot to be desired, but it's what we have. So there's a question then also of how you integrate that in a uniform way with what you have going forward, which may be much better. Okay. I should say that the group was, the specialties in the group were one person doing big data tools, two doing traffic and traffic data collection, three people doing species distribution or related things, one on data preservation, one who is specifically interested in validating data and expressing the results to the public in a way that could be believable or influential, one who is theory algorithms person who would like to have the shared data, and one on power grid, and one, well, half on power grid, half on climate, which is me. So we have both. Not a lot of discussion of climate here, although that could be I would assume that's a strongly related issue. Let's see. We also had a fair amount of discussion about privacy and so on, although I'm not sure we really came up with anything that was a great insight or would give you great. It's clearly a problem, though. Many of the data that we collect from cameras, cell phones, monitors in vehicles or whatever has privacy issues, and we have to live with it and work with it. So I think I'll stop. Okay. Yeah, sure.
We recorded every single thing that happened in the world.
Whatever that means, right?
How much data would that be?
Well, they say that there's about
Well, I mean, you could record electron spins or something. I mean, the total amount of data potentially is just crazy. I don't know who the answer. We'd have a better estimate of what's actually being collected. Yeah.
60 frames a second, cameras every 100 feet.
Yeah.
No, no, and that's sort of what is, it's Cisco and people like this, integrate do these.
My guess, the answer to the question is that probably the satellite data is the largest volume, and so if you took that and multiplied it by 10, you'd probably have a bound. I don't know.
There's not that many satellites.
No?
It's all the videos out there.
Well, that's true. Videos, yeah.
I think it's more consumer level stuff. When you have
YouTube. Yeah. I don't know.
That means that we have to make a choice.
yeah, we can't say.
Can't say everything.
Yeah. Okay.
Sean? So this is system integration.
So our group talked about system integration, and then we had a much broader discussion towards the end. So we started with this issue of interfaces and how to design interface to enable integration and interoperability. We talked about whether interfaces that we see right now are rich enough. What techniques could you use to do integration? The issue of using semantic web technologies to do this kind of integration came up. Someone pointed out that mashups are essentially a form of data integration across diverse services. And web services do something like this, although none of them seem to exactly fit the pain points that you see in this domain. So there are issues like large amounts of data, unstructured data, and things like that, and what kind of interfaces are necessary to enable integration of systems and data. So that led to some additional discussion on whether data integration is it. And then it was pointed out that in these kinds of systems, you also have actuation. So you need to integrate systems that not only produce data, but also actuate. And then what kind of interfaces are necessary to do that. In the context of simulation, someone pointed out that you actually need to integrate across models and have workflows that allow you to couple simulation models to do much larger scale simulations of sustainable systems. And then we asked the question of, are there system integration arises in many different contexts, and one question we wanted to answer was, are there unique challenges in this field, in the field of sustainability, that we need to address? Two points came up there. One was performance matrix across layers, and so there are many layers that you need to consider when you talk about sustainability or any system. What kind of matrix are appropriate? What kind of data is produced? How do you reason about this data across different layers? The other point that was made was the reason this is harder, system integration is harder in this domain, is because the domain is more heterogeneous than other domains. There are lots of parties, there are lots of layers, lots of different kinds of systems. So integration will produce challenges that you may not have seen in other domains. So one point there was whether standards would help, and then the counterpoint there was, given the number of players that are sort of looking at various aspects of this, there will be many different standards, and these standards are not going to interoperate. So an example was in the smart grid, you have the meter companies, you have the utilities, you have the sensor people, and each of them have their own different standards. So that really is not going to solve this problem of system integration. We talked a bit about granularity of data and the fact that you have different granularity of data that you see in this system. So if you really need to integrate, you need to understand what are you trying to measure, at what granularity should you measure it, and then try to do some integration at that level of granularity. The issue of distributed control came up because you're trying to integrate across systems. You need algorithms, systems that can do control across systems that don't necessarily talk to one another. So how do you do that? What does distributed control mean? What kind of signals do you expose so you can do this kind of control? So we talked about this issue of, in this context of granularity and matrix, we also talked about how to do the measurements to avoid this notion of double counting. So if you want to measure carbon footprint, for instance, and attribute it to various factors, how do you ensure that you don't double count across factors? And someone pointed out that the financial people know how to do this, or maybe not. So maybe we should learn from them or not, or learn the right lessons from them. So we talked a little bit about education issues, and then what kind of system integration projects can we give to our students, what tools are available to teach students how to design systems for better integration, and what kind of repositories can we build of educational materials in this domain. And that basically led to a broader discussion of why we are even talking about system integration and this notion of culture and evolution, and whether IT can actually help, and IT and system integration can even help. So what people felt was the basic point that was made earlier in the morning was this basic human instinct. Basically, it causes you to trend towards consuming more. Cultures are trending towards consuming more. IT by itself is not going to help in this context. And so how do we actually change our culture and our mindset so that less becomes more and not more is more? And then finally, we talked about what role IT can play in the context of ensuring proper data interpretation, not ensuring that data is misinterpreted or there's misinformation that people sort of see within the same data set, whether IT can help in that context. So this is just some broader topics that sort of we discussed towards the end. Things we agreed on: need for interoperable interfaces, the need to do proper accounting and have proper metrics. Things that we couldn't quite agree on, someone mentioned whether we should have open architectures, and it was felt that given the number of players, that is not something that is going to happen. How do we do proper accounting? As I said, something we couldn't quite figure on. Whether there will be one standard is something I think is really an open question, unlikely to happen. So that's it.
So would the Regency C group like to offer some comments?
Thanks. So we were apparently the rogue breakout group. We all just stayed up here and chatted. But so they've asked us to report. So I apologize in advance if we didn't take notes until after the fact, because we didn't realize we were a breakout group until later. But in general, you know it's a good group when you've lost your voice by the end. So I apologize for even being froggier than I was in the previous talk. But so some of the things we talked about the relationship between the non-industrialized world and the industrialized world as it relates to a lot of these problems. And then we also spoke about responsibility and leadership in this area. So the metaphor of parenthood came up as one aspect of it. Also the notion of the China versus the U.S., where in China, you know, the top administrators can say, we're going to do this, and then that ripples out pretty rapidly, whereas in the U.S., achieving a consensus requires a little bit more undertaking. The example from California was also brought up, though, the notion of sort of sharing the pain that Jerry Brown is putting forth in terms of the economic constraints. That was sort of seen as the flip side of the mutual benefit that is often looked for. We talked about economic issues quite a bit, both in the short-term and long-term sense. In particular, talking about how to account for the real costs that underlie a lot of the systems, and how IT can potentially support the accounting for the real costs of all the things we're surrounded by, and how micro and macroeconomics can help in some of these things. And so, should we reach out and try to collaborate more with economists? We touched briefly on totalitarian agriculture as potentially being at the core of some of the challenges. The idea that the desire to grow lots of food and store it is part of the cultural challenge that we're having. We talked for a bit about IT to display data and to increase consciousness around a lot of these issues, and also potentially about the use of humor in those contexts as being important, especially in educational settings, and in making these ideas appropriate to children. There was some talk about how sort of waiting for the old guard to die off so that we can so that the kids these days can do it a little bit better. we continued the debate about efficiency for a while, chatting about in what context efficiency might or might not be beneficial. And we talked about whether or not CPSR still exists, Computer Professionals for Social Responsibility, and whether that might be a venue for some of this stuff. And one thing that I thought was very interesting was that we talked about how to close the loop in terms of some of the legal things. We talked about the legal issues that were at the heart of some of these problems, and can we somehow make dynamic laws that can help to close the loop? So rather than it's saying you need to achieve 350 parts per million, instead have something more like we need to achieve a level that this scientific group decides upon what the right level is. So there can be this continuous feedback loop rather than just sort of having a one-way street in terms of the law, having the law have some feedback functions built into it, and whether or not society would be able to accept that. So we talked about all sorts of other stuff that was really interesting. So I wanted to offer the people who were part of that group, anything I missed? Anyone chime in on? Okay, well that's what the Rogue breakout session talked about. Thanks.